Hello and welcome to Database Management Systems. I'm Javita Christie, and in this video I'm going to explain joins and outer joins in structured query language. So let's start. We'll begin with joins, and I'll show you how you can do joins in SQL in different ways. Suppose you have a query that says, find the names of all people who work in the consulting department. Now, this is not as simple as doing select first name, comma, last name from employees, where dept code equal to CNSLT. That is how we would have done it earlier, and we're not going to do it that way. And I suppose that if you are on this video, then you must have already created the database that I'm using here. If you haven't, then please go ahead and watch those videos about the database and create that and practice along with me in this video. Now the query says consulting department. So consulting department would mean that it's the name of the department and not the code. Otherwise it would have been mentioned here CNSLT, but it's not. So you cannot directly write this query. You require the name of a department, which you can get only from the departments table. And you require names of people, which you can get only from the employees table. So this is the case where you have to take a join between the two tables. And if you have watched relational algebra videos on natural join, you would know how to take a natural join and conceptually be able to understand what that is. But this is where we practically perform it. So if you don't know the concept of natural join yet, then you can go and watch the relational algebra video, which I have linked below. And then this video will go much easier for you. So this is the answer. Select first name, comma, last name from employees, join departments, and then I'm writing on, and I'll tell you why I've written this later on. And then I've written where name is equal to consulting. And you can see that these are the values that I get as a result of this. And let me just show you the database. So these are the 4 tables we have. And from here, we are using the employees and departments table. So we are using these 2. And you can see that whatever is highlighted in blue is a foreign key that is borrowed from some other table or from the table itself in the case of departments. Whatever is underlined is the primary key. Now you can see that there's a connection between employees and departments using the dept code from here and the code from here. But you see the column names are different. Here the name of the column is dept code, but here it is code, which is why in my previous query I have used this. I've used on dept code equal to code. The reason you know now, because the 2 columns are foreign keys, but they are having different names, and which is why I used it in that way. And you can see that I can get the name of the department consulting from here, and I can get the first and last names of all employees from the employees table. So this makes my work easier by taking a join using the on keyword. So this is your query. You can go ahead, pause the video, implement, and come back to the video. Let's now move on to the next query. Find the names of all people who work in the consulting department and you spend more than 20% of their time on the project with ID ADT 4MFIA. So they are, this is quite a bit of a query, but it's not really that difficult. And once again, now all the times that are mentioned in our works on table, they are mentioned not in percentage form. So whenever the query says 20%, you need to consider it as 0.2. So it's always divide by 100 and then you consider it. And that's all right. So let's see the answer to this. So this is how you can do it. Select first name, comma, last name. You need all the names. So we are selecting both the columns from employees, and then again taking a join because we have been told that it's a consulting department. So this is just like our query before. So there's nothing new here when I'm doing employees join departments on dept code equal to code. Up to here, it's the same as the previous query. But then I also require the data that says they should be working for more than 0.2 time, assigned time on the project with ID this. So I need to take a join with the works on table too. So that's why there is a join after this with the works on table. And you can see that instead of the word on, I'm using the word using. And I'll let you know why in a bit. Okay. And then we are writing all the conditions. So first you take all the joins, and once you're done with all the joins, then you specify the condition using the where clause. So now the where clause comes in, where I'm writing name is equal to consulting because the name of the department is consulting. And then the next condition is that the time should be 20%. So I've done and assigned time greater than 20%. And one more condition is that the project ID should be ADT4MFIA. So that's what I've added, one more condition over here. And after doing all this, this is the result that I get. And now I will tell you why I chose the word using. So you can see here that in the works on table, the connection between employees and works on is the employee ID, which is similar. Now you can see here also it's employee ID, and here in the employees table it is employee ID, which is why I have used the keyword using and not on. When we took a join between employees and departments, we used on because the column names are different. But here the column name is same, so it doesn't make any sense to write down employee ID equal to employee ID. So we are just going to take the word using and write down employee ID because both tables have that column. So now I leave it up to you to verify the data which we are getting, the result which we are getting, and you can view it here. So I think the best way to verify it is to go and check over here how many people are in the consulting department. Of course, there will be a natural join, but we already know from here that the code of consulting department is this one. So we see that there are two people, Suzy Software, Abe Advice, and then when you take a natural join of this with works on, then Suzy and Abe are having employee ID 4 and 5, and 4 is coming here, 5 is here, 5 is here. So 3 rows are selected. And out of these 3 rows, all of them are having greater than 0.2 assigned time. And which is why, as a result of the previous query, we are getting this particular name, Abe Advice, because there's one more condition that is ADT4MFIA. So let's see. There's only one person working. Out of the 3 rows selected, only employee ID 5, that is Abe Advice, is working on this particular project ID, and that's why that is what we got. Please go ahead and take your time to pause the video at any point, at this point, I would say, and implement the query on your own and come back to the video. Let's now proceed to our next query. This is find the total time assigned to employee Abe Advice. So whenever it says total time or average time, that is where you are going to start to use the aggregate functions. So this is that type of a question where you will be using aggregate function. So you can see I'm using an aggregate function called sum to perform this query. So I'm going to do select sum assigned time from employees. Now I should know that the name of this employee is Abe Advice. So I have to do a join between employees and works on, and using employee ID because both of them have the same column. And then I'm going to write where first name equal to Abe and last name equal to Advice. So how this works is, this is our database and this is the employees table. This is the works on table, as you can see. So these are the two tables being used. So what happens is when you take a join between the two, then the common employee IDs will remain. So using those, now you can fetch Abe Advice, and Abe Advice is having the ID 5. And if you look here, it is coming 2 times. So once it is for 0.5 assigned time, and second time it is for 0.6. So if you do the total of those, you get 1.1, which is correct in this query. So this is how you can do it. And I encourage you to go and practice it on your own and then come back to the video. Let's now see our next query. This says, find the descriptions of all projects that require more than 70% of an employee's time. Again, 70% we will be considering it as 0.7 because all our values are stored in that manner. So it's going to be 70% would be 0.7. This is how you are going to write your query. It says select distinct description, and I've used the keyword distinct explained in one of the previous videos. Distinct is used when you want unique values of something, and in this case, if you don't use distinct, you'll get multiple times the same value. So I've used distinct description because it says description, and from projects join works on, because works on would contain the data about how much time is given to each employee for a particular project. So there is a natural join between projects and works on. And the keyword here, the column used is project ID, which is again common between the two. So you can use the keyword using instead of on. And then the condition is that assigned time is greater than 0.7 and the result is robotic spouse. So we'll just check it out. So we are using the projects table and the works on table. We are using these two. Between those two, the project ID is common. And what we want is the description of a project. So first we are checking in the works on table, how many projects are there that have time assigned greater than 70%. So we can check over here, it should be greater than 0.7. So when you see, there are only 2 rows which have that. So these 2 rows have 0.75, 0.75, so that is more than 70%. But in both, the project ID is the same. So it is Robo SPSE. And now when you see in the projects table, you can see that Robo SPSE has the description robotic spouse, which we are producing as the result of the previous query. But you know now why I used the distinct keyword, because if I would not, then this thing is coming twice, Robo SPSE. So even robotic spouse description would be coming twice. So you would get 2 times robotic spouse, which is why I had to use the description distinct, the distinct keyword before description. Please go ahead and try the query out on your own and then come back to the video. Now we move on to a different type of join, which is the outer join in SQL. And again, to understand the concept and the logic behind the outer join, you would need to watch relational algebra outer joins. which I've linked down below again. So you can watch that first if you haven't, and that would make you understand this concept over here better. So let's start with the query. It says, for each employee, list the employee ID, number of projects, and total percentage of time for the current projects to which she is assigned. Include employees not assigned to any project. Here the word she does not mean you only fetch female employees. You have to fetch all the employees. Now, this is using several concepts together. So I'm not going to explain the query first. I'm going to explain the answer. Now this is the answer. So first of all, the query says that you need to count how many projects are assigned. So which is why I have, it says number of projects right here. So that's why I've used count assigned time. You can use count project ID. It would do the same kind of work, and that's all right. So you can use count project ID or count assigned time. You can count any column, because in works on we don't have any null values. Then it has, you need a number of the total percentage of time assigned. So that's why we are doing some assigned time. And for each employee, you need to find something. So we are just displaying the employee ID. You could display the first name and last name too. That would be fine too. And the reason why we need a join, because you might think that, okay, everything in the select query is having things which are already present in works on. You are using employee ID and assigned time. Both are present in the works on table. So why use a join? The reason is right here. It says include employees not assigned to any project. So you need to include all those employees who are not assigned to any project at all. And that's why we are using here the left outer join, because left outer join would preserve all those values from employees table that do not match with works on table. Only then can you include employees not assigned to any project. So I'll just show you here with my tables that are given here. So we have the employees table and the works on table. Now here you can see the IDs that are coming are 2, 3, 4, and 5. But the IDs 1 and 6 are not present in the works on table. So if you want that data, if you want to know which employees are not given any work here, then you have to take a left outer join. If you take a left outer join, then you will come to know that these two employee IDs are not assigned any work from here. So that's why we are using the left outer join. And you can see I'm getting 6 employee IDs. And I've also used group by because I want all these details per employee. So that's why I've used group by. And group by has already been explained in the previous video. Please watch it if you haven't. I've linked it down below. So group by employee ID, which would make sure that I get this count and sum per employee. And now you can see that you are getting all the employee IDs. You're getting 1, 2, 3, 4, 5, 6. So 1 and 6 are not present in works on, but I'm still getting those. And you can see that the assigned time for those is 0, and the sum remains null because they are not assigned anything and they are not assigned any projects. So that's why it's a 0 here. And for the remaining employees, the total projects are counted and the total assigned time is counted. We can verify one, you can verify the other on your own. So let's see the number 3. You can see that number 3 is coming twice, and number 3 is Harry Hardware, who is assigned 2 projects. So it is showing 2, and of course the total time would be the sum of these 2. So that's what a left outer join looks like, and everything else remains the same. You will still be using the word using because the column name is same between employees and works on. Please go ahead and try the query on your own and come back to the video when you're done. The next query says, find the description of all projects with no employees assigned to them. So now there are no employees assigned to projects, and for those projects, I want to find the description. So if you understood the previous query, you'll also understand how to do this one. It's very easy if you got the previous one. Now in this case, we want descriptions of projects which are not assigned to anybody. So again, you have to take a left outer join to get this information. So I'm taking a left outer join between projects and works on. And you can note, if you notice, then in the previous query, I wrote left outer join, and in this I wrote left join. And in Oracle SQL, SQL Plus, the software that we are using, this is allowed. So you can use, instead of left outer join, left join, and it will do the same work for you. Now between projects and works on, the common column is project ID. So I'm going to make use of the keyword using project ID. And then how do I know that one particular project is not given any employee to work on? By putting this statement, that is where employee ID is null. And the result is employee moral, which we are going to verify now. So this is the projects table and this is the works on table, and between those two tables we are going to make these comparisons. So let's check it. Is the project emp happy present over here? No, it's not. So employee moral is not present. And if you check, then these three projects right here, these three project IDs are present, which means they are given some employee who's going to work on that. But only this particular emp happy is not present here, employee moral. So that is what we are also getting there as a result. And so that's why our query is correct. But to get this value, you need to use a left outer join, because when you perform a left outer join, then anything from projects that does not match with works on will be replaced with a null value. So emp happy will get matched with works on, but at that time it will have an employee ID which is null, and that's why we used this where employee ID is null. So this is the query for this particular question, and I'd like to point out that you might want to use a right join also. So in SQL you have left join, you also have right join. So both will do the same work. But if you want to use a right join, then you just have to interchange projects and works on. So here you will write works on, and here you will write projects. Then you can replace left with right, and it would do the same kind of work for you as the previous join. So left and right are same, it's just the way of looking. You can just interchange values, and you can use left instead of right, it is all right. So please go ahead, practice this query on your own and come back to the video. Now the next query that we are going to do is, for each project, find the greatest percentage of time assigned to an employee. So this is again going to use that particular type of join which we saw earlier. And we are taking that join between projects and works on. And I've used one extra function here called NBL, which is the null value function. And what that does is, if it finds a null value in some column, then it will replace that value with 0, not replacement within the table, because select query never changes anything in the table. But it replaces for calculation purpose with a 0. And now the query says that for each project you need to find what is the maximum assigned time to an employee. So we need to use the group by keywords, and notice that whenever there is a word in the query that says each, you will be using group by most of the time. I'm not saying that happens all the time, but most of the times when there is each in the query, we need to use group by. So now I'm selecting description from the project so that we get a good name of the project instead of the ID. So I'm selecting the description and then finding the greatest percentage. Now this could be done without a left outer join, but then all the projects will not come, as you know, because there is a project called employee moral, which is not given any kind of project. So the assigned time, maximum assigned time for that would be 0. And in order to display employee moral, you have to take a left join, just like the previous query. So I have done the left join, and you can see that the max time is 0. This would not be 0 if you had not used NVL function. Then it would just give you a null value. So in order to get a 0 here, you have to use the NVL function, where if some value is null, then it will simply replace it with a 0. So I hope that this query is quite clear to you. It's not very difficult. It's just requiring the maximum time. So let's go and just very quickly verify it. So download client, which you can see is here, is having maximum. It has only one data here, so that's why maximum assigned time is 0.25. For the robotic spouse, there are 3 times it comes here, and the maximum time is 0.7. So you can see here it is 0.7. And then Mofia audit is having 0.6, which you can verify here. It's coming twice, and 0.6 is the max. So, and of course employee moral, which does not come at all here. So it would, you can say that it is assigned maximum time of 0, which also we have covered here. So this is how you can do this query, and I would request you to practice it on your own so that you can understand it better yourself. And the rest of the SQL will be carried on in the next video. So please go ahead and watch that. And thank you for watching this one.